Professor Marsden has some, I guess, unique things about how he's teaching. For one, his nomenclature isn't standard IUPAC. He has his own way, like it's close enough, but there's some differences between his way and IUPAC. Another one is the concept of bunny hop. I've seen students like kind of get confused about how he notates some of the arrow pushing because they've never really been exposed to his bunny hop. So if you take Dre A and Dre B with Professor Marsden, it really helps because he keeps like his uh, his own habits throughout both of them. So bunny hops are how he kind of notates like electron movement throughout a reaction. So for this one, right, we want this is starting material on the left and then whatever we want on the right. I think traditional ways to teach it would be just drawing the arrows like one by one. Right, so the lone pair on nitrogen will move to that bond and so forth. So you'll get a lot of steps like these. How Professor Marsden does it is he'll actually notate like where the electrons end up before moving to the next step. So right, nitrogen goes here, and then what happens is that you actually have something like this. So it's kind of like a arrow that has a little indent in it, but this is how he notates that the electrons from this double bond will actually end up on this carbon. Right, so the intermediate step would be something that looks like this. And then whatever is on the other part of the molecule. Right. Because of resonance, you're going to have a negative charge on this carbon. If you just draw like one arrow from the double bond towards the other bond, you're not going to really see this step. So having the bunny hops are his way of just kind of showing how things move. So if we complete this kind of resonance problem, then what we have is once you have a double bond here, this double bond has to move somewhere else. What you do is you do another bunny hop onto this carbon, right? And then forms the bond there, and then your last double bond will move to nitrogen. And that's how you end up with this one. A negative charge on nitrogen, and then on this nitrogen, and then the positive on the other one. It's a good time to point out that on exams, Professor Marsden will very usually give you like instructions on how he wants the answer to look like. For example, for this one, he might label the nitrogen, this one as like B, and nitrogen, this one as A, and he'll have a box, and then the question will just be like, hey, draw a resonance contributor with like a negative charge on nitrogen B and a positive charge on nitrogen A. So hints like that will tell you kind of how to approach the problem. On many of the exams, especially mechanisms, like it might be very daunting to start doing the mechanism, like you won't know which steps to do. He'll usually give you hints on what intermediates he wants. Like if it's an enolate being formed, then that gives you clues on how to approach it, and then like how to move on from it. So that's a very good thing I found from his exams, is that they're very clear on how he wants his answers to look, and it also gives you hints on how to do it. So this is kind of Dre A material. When we do Dre B material, if you get to the EAS reactions, so electrophilic aromatic substitution, this is another place where bunny hops are very useful. So I mean, first you'll learn that in all the mechanisms you really want to first activate, then attack, then to kick out leaving group, and then just readjust that steps once you go through the mechanism. So first you want to activate the oxygen. So you get something like this. Double bond benzene. So in EAS, what we do is we can actually draw that bunny hop again, and it makes it clear like how this reaction is proceeding. There, too far. You get something like this. This is a positive charge, and you break the bond. One thing also to note while I'm doing this mechanism is that he has a lot of points on charges. So if you're able to, keep track of charges, and even if the question doesn't ask you to explicitly like draw in charges, he expects you to do so. So whenever you have charged atoms, do draw them in. Sometimes you get extra credit, or not extra, partial credit. Like if you get the entire mechanism wrong, but if you have the charges correctly, he'll still give you points for the charges. So what do we get from this? We get this one opens up, and we have the benzene's now here. Right, and then we'll have a positive charge, right? Because we took the electron from the double bond. Now, the topmost carbon has a positive charge. Right, and then since we have a chlorine molecule here, what you can do is take the hydrogen here and then reform the double bond, and then you end up with the molecule there. So having a bunny hop, I found it pretty helpful because this is how I learned it, and it seems more intuitive than just drawing in like the just one arrow without the bunny hop. Yeah, so sometimes Professor Marsden will teach things differently, and it's a good idea to pay attention because that's how he's going to expect them on exams and whatnot.